Hello, everyone.
Welcome
Welcome
back
back
to
to
the
the
final
final installment
installment
of
of
the
the
Tapes
Tapes
podcast.
podcast.
I'm Jaden Luciano Calderon
And I'm Anthony Giovanni Santos Mendez, joined
eh,
here by our special guest.
from Africa. He
He
came
just
just
immigrated
came from
here.
Africa.
How long have you been here for?
8 years.
Why are you lying? But anyways, tell us your
Anyways,
name,
tell us your
mysterious
full name.
stranger.
Your full name.
My name is Wealth Clinton Duefe Michael Agbore.
Yes. Thank you. um. So, Anthony, what is this unit?
Our last unit is Unit 9, Global Change. And this unit of apes accounts for 15 to 20% of the total exam weighing.
Now, Anthony, you know what I'm gonna ask you. How
Yes,
much
and
and what does that mean? What does
and as per tradition, I'm gonna tell you I don't know what the that means.
um
you have to cut so many things out.
I keep some of the curses in.
Should we begin?
We should begin, Jaden.
Okay, so the first thing you will learn in this unit is stratospheric ozone depletion. Kind of like how Walt's hairline depletes backwards. But stratospheric ozone depletion. So there's two locations for ozone in the atmosphere. The tropospheric ozone, also known as photochemical smog, is not naturally occurring, and it forms because of the secondary pollutants.
It's also a greenhouse gas. It's
yeah.
also a greenhouse gas. Yeah.
And then there's stratospheric ozone, which is
it protects us from.
okay. There's stratospheric ozone, which is a naturally occurring ozone, and it protects us from the sun's UVB and UVC rays.
Mm-hmm.
Um,
So, Jaden, there are 3 different types of UV rays. Can you
yes,
tell
and I
us
will
about
describe them for you. So first we have UVA rays, which the ozone absorbs at least
the
or
least
the least
amount,
amount of UVA rays,
which
like
is
5%. And then UVB rays, which the ozone absorbs the most rays, which is 95%.
Mm-hmm.
And then UVC rays, which are the strongest, most energetic rays. The ozone absorbs 100% of UVC rays.
This is important because UVC rays are by far the most deadly type of UV rays.
Which is deadly as well scalp.
I'll explain more about like the ozone formulas. So the breakdown of the UVB rays is when ozone when in contact with UVB radiation splits into O2 and like free oxygen elements, and then the free oxygen element joins another free oxygen element to form O2, which is stratospheric. I forgot what that is. I forgot. And then UVC rays is when O2, when in contact with UVC radiation, splits into like free oxygen elements, and then that free oxygen element forms a O2 compound to form ozone.
Okay, so Wolf Clinton Aldufe Michael Agbore.
It forms with O2 combines with
That's what it has there.
combines with O2.
Too bad.
I just said that. A free
Anyways,
oxygen molecule.
Wolf Aldufe Clinton Michael Agbore. Do you have anything to say about what we just said?
I don't really have anything to say besides the fact that other than the ozone layer with O2 and splitting apart into O to create the stratosphere, the stratospheric what's it called?
Ozone.
Yeah, the stratospheric ozone. The chemicals that provide it. When the O2 is split into the atmosphere, it also combines with other compounds like nitrogen and nitric oxide to create acidic compounds that rain down on the Earth, which is the cause by greenhouse gases splitting in the atmosphere and combining with the O2 molecules.
We already discussed that, but
I'm just adding on,
okay.
to refresh the
So
memory.
here we
We have a
have.
phenomenon known as Antarctic Spring, which is when the Antarctic winters create stratospheric clouds full of ice crystals, and in the springtime, which the Antarctic is located in the southern hemisphere, so that is in September. And in the springtime, these crystals melt, and then chemical reactions convert chlorine into a more reactive form. Chlorine, like this is important because chlorine degrades ozone into stratospheric oxygen by breaking the oxygen bonds, which thins the ozone layer.
Mhm.
And another thing to know about is chlorofluorocarbons, which are CFCs. And these CFCs contain the element chlorine, carbon, and fluorine.
Fluoride.
And this is important because when chlorine is in the ozone layer, the chlorine breaks ozone bonds and joins like a split oxygen element to form ClO And then when this ClO comes in contact with the free oxygen element, it splits back off into the free chlorine element, repeating the cycle. It's like a cycle.
Mhm.
Like the chlorine breaks off. Is that Wingstop?
We are trying to be professional.
Anywho, continue, Anthony.
This is destructive because chlorine will keep on breaking the ozone bonds, which in turn thins the ozone layer.
Wolf, would you want to discuss something?
Do you want to talk about? Do you want to talk about the effects of ozone depletion?
Some effects of ozone depletion include number one, thinning of ozone layers, especially at the poles, which we can see has a lot of effect. Like let's say, in recent news in
They
Antarctica,
can't see it, Wolf.
Can't see.
as we can see in recent news about Antarctica, about the ozone depletion, we can see that a lot of the ice sheets and glaciers in Antarctica are starting to melt, which is causing the ocean levels to rise because of such a thin ozone layer. And number two, the disruption of terrestrial photosynthesis. Because of the change in temperature, a lot of ecosystems are unable to perform proper photosynthesis, as those plants are not accustomed to such climate changes. And also the disrupt disruption of photosynthesis by phytoplankton, because the phytoplankton are starting to die off in the ocean because it's getting too hot, like they're being boiled alive. And disruption of food chains and food web, as one of them previously discussed, saying, oh, in the previous unit when we were talking about biomass amplification, with the other the lesser
He's just like, yeah.
levels of the trophic triangle being destroyed, it goes
Does he even know
on
what
to
he's
the
talking
higher
about?
levels, causing all of them to like fall apart.
Did you
And impacts
like
of
how you spell
population
it?
of some organisms like amphibians.
Like it's just on the side. Just
Yeah, like I
this
was saying,
side.
like a lot of
Like when
animals
I'm
are starting to
texting.
die off because they're unable to adapt to the increase in temperatures. And
Right.
impacts on human health, skin cancer, and cataracts, which we can be seeing in Jaden's eyes because he's going a little blind, and so is Anthony's.
Yeah, it's fogging up the lens. All that stench from in between your legs, fogging up my lenses. But anyhow,
So Jaden, we're talking about how bad like ozone depletion is, but how do we reduce ozone depletion then?
so we have created different acts. So like the Montreal Protocol,
Mm-hmm.
it's an international treaty that phases out the use of chlorofluorocarbons,
Mm-hmm.
and this
And
started
we
using.
also started using alternatives, yeah.
We also started using alternatives like hydrofluorocarbons, which is
Which
hydrogen, fluorine, and carbon instead of the chlorophyll, the
Mm.
chlorophyll,
chlorine,
chlorophyll,
chlorine,
chlorine. Oh my god, chlorine.
but
Um,
these HFCs they also emit greenhouse gases, so like it's
yeah.
lessened, but it's still pretty bad.
So now we're gonna talk about the greenhouse. Oh, yeah. Go
Sure.
ahead.
So as my fellow podmates were discussing about, like, there was the ways that they're trying to prevent the
You know how
depletion of the ozone layer.
you know how
There's also
the
been
blue bag
an update on the news recently. I can't remember what it's called, but there's a substance that they release into the atmosphere, a crystal which destroys the chlorine acids and gases in the air and bond with the oxygen atoms to make this ozone layer stronger. Which I think that's a really good idea, and like we should study that furthermore as a way to rewind the effects of the greenhouse gases that we've released into the atmosphere.
Yes, thank you. Thank you. So the next thing we're gonna speak about is
Is the greenhouse effect.
so the
Jaden.
greenhouse effect is incoming solar radiation that is reflected back into space that interacts with greenhouse gases in the atmosphere, and it re-radiate it's like re-radiating rays back to Earth.
So can I explain that real quick?
Sure. So it's basically making Earth hot.
Yeah. So like basically when like ooh solar fragment. So like when these UV rays hit the Earth, some of them are bounced back into the atmosphere, but these greenhouse gases they actually absorb the UV rays and they like disperse them back into the Earth,
Uh-huh.
which in turn makes the Earth hotter.
Yeah.
So basically, for the weak-minded people, it's the greenhouse gases act like an insulator between the ozone layer and the atmosphere, because as the heat goes to the ozone layer, like it doesn't escape like how it's supposed to. The greenhouse gases catches them and puts it back on the earth.
Anyway, thank you all for that insightfulness.
So
Um.
Jaden, where does the greenhouse effect take place?
So the greenhouse effect, um, it takes place in the troposphere, And the process of the greenhouse effect stabilizes the Earth's temperatures because of the solar radiation emitted heat.
emitting heat. So these greenhouse
Oh, okay. So it's the process of the greenhouse effect stabilizes Earth's temperature because of the solar radiation emitting heat. Mhm.
and these greenhouse gases includes carbon dioxide, CO2, CH4, which is methane, H2O, which is water, which isn't really that bad of a greenhouse gas because it like easily leaves the atmosphere.
And it's always found in the atmosphere.
Yeah, and N2O, nitrous oxide, CFCs, HFCs, and photochemical smog, which is just O3, which is in the form in the troposphere.
Oh, why
Um,
you queef? Anyways, continue.
Carbon emissions um, include transportation, which is 34%, electricity, which is 32%, industry, which is 15%, residential, 11%, and then other, 7%. These like forms of energy use all bring carbon into the atmosphere. And then methane emissions include enteric fermentation, which is the digestive process in mammals, which is 28%, natural gas and petroleum systems, also 28%, landfills, 17%, manure management, 10%, coal mining, 8%, and then other 9%. And nitrous oxide, most of its emissions come from agricultural soil management, which is 78%. And then CFCs and HFCs mostly come from the substitution of ozone depleting substances, which brings 92% of most emissions.
Going back to what Anthony was just speaking about what causes like the emission of these gases. Speaking of methane gas, one of the major causes of methane gas release emission is from meat factories and meat farms in which they domesticate mammals like cows and goats and other stuff. And these cows, they produce a lot of methane in their body through the digestion of the food that's given to them. And when these meat factories kill these animals and produce them unethically, it releases a lot of methane gas. Not to put in the energy that's being used to produce these animals, the carbon being emitted from the machines and the water and all those other things, which is also like a really big issue at the moment with people debating about the ethicalness of factories and other stuff.
We actually did talk about this in Unit 5, Walt, so thank
I
you for
was not
telling us.
aware.
But it's
Okay,
it's
this
it's
is a
great that
preview.
they're relearning
Review.
it. It's like always good to
It's
know.
always so good to relearn from the source.
But from the source, yeah, from the big source.
Okay, so let's continue. So continue with the greenhouse
Mhm.
effect. There's also something that you need to learn called global warming potential, or GWP. This is the effectiveness of a greenhouse gas radiating heat. So carbon dioxide has a GWP of 1, which is like
Which is the
standard.
standard.
Methane has like a 20. Nitrous oxide has a 300. Ozone, which is O3, is like
In the
900 to
troposphere.
1,000.
Mhm.
And then CFCs, they account for they have like a 4,600 to 10,000 GWP. And then HFCs have 150 to 12,000 GWP. And as you can tell, CFCs and HFCs are something to focus on, especially with its global warming potential.
Yes, Jaden. Thank you for that. So
Okay,
yes,
so
well, we would love for you to discuss this topic.
oh no,
This
please
topic
no.
is the increases in the greenhouse gases.
Oh, the tickets.
Go.
Oh,
Yeah.
so increases in the greenhouse gases include concentration of greenhouse gases have increased in the atmosphere as a result of human activity, CO2 slash methane emissions, as we discussed. Increases in greenhouse gases and increase in annual temperatures. Application of the greenhouse effect leads to rising sea levels, as I discussed earlier. Land ice, like continental glaciers and ice sheets, melt, adding volume. Thermal expansion of the ocean is due to global warming. Rising sea levels are detrimental because rising sea levels destroy coastal communities, coastal habitats like Venice. This too, disease vectors expand their range. Global warming allows for species like mosquitoes and ticks to survive in once hospitable land for them, which can be seen in the increase of malaria in other countries in which it was not previously seen. Three is habitat loss. Oceans grow deeper, no longer shallow habitats. Loss of food source, trophic type pyramid. If prey get affected and die off, so do prey on higher levels and on the trophic pyramid. Storms are intensified. Forest fires are more likely to occur. Migration and hibernation timing is altered. Do you want me to continue? This is global climate change.
So continuing with global climate change, climate change has been increasing quickly. It's exceeding the maximum values since the past 800,000 years because of the greenhouse gases in the atmosphere that we discussed.
So Jaden, I'm gonna go over that real quick. So basically, over the past 800,000 years, it's gonna be quick. Over the past 800,000 years, there has been like periods of like climate change, like when the Earth is like really hot, and then when the Earth is like really cold, which is like the ice ages.
Sí, señor.
And right now, it's been increasing rapidly because of greenhouse gases in the atmosphere, as you just mentioned. So you can continue.
Um, So changes in the temperature can also affect changes in air circulation, the Hadley cells and convection currents and jet streams, like we discussed in the previous topic. Changing wet, right, cool, dry, and wet winds, which changes habitats, biomes, and global weather patterns.
Mhm.
Then there's also soil erosion through evaporation, which is leading to dry soil and desertification.
Mhm.
um, and then there's polar ice,
Which is melting.
which is melting, leading to a decreased albedo, which we also discussed in a previous topic. Okay, so permafrost is located in tundras, is melting, releasing methane into the atmosphere. And then lastly, sea ice is melting, removing polar bears and species that depend on sea ice habitats, which is also raising the sea levels, and then will also increase the heat on Earth.
Yes. Yes. I'll talk about this. So, another unit that you will learn about is ocean warming. And ocean warming is defined as the global increase in ocean water temperatures. And across the globe, ocean warming isn't like uniform, it's not uniform. So, and some areas warm more quickly than others. What happened? Oh, brother. And ocean warming is caused by increased greenhouse gases in Earth's atmosphere. And the effects of ocean warming is rising sea levels, which we already discussed, thermal expansion, loss of marine habitats like polar bears that depend on the sea ice, um, rising coastal areas, which pushes communities out of the photic zone, which, if we recall all the way back in Unit 1, you remember the thing that we were talking about how, like, as you go deeper, photosynthesis is decreased?
Oh,
Yeah.
yeah.
Deeper into the ocean.
And the ocean warming also leads to a phenomenon known as coral bleaching, which is the removal of vital algae in coral reefs. Um, and the thing with that is that coral and algae, they have a mutualistic relationship. So when that happens, the coral expels the algae because of the rising temperatures, which gives them a white or bleached look.
Then there's metabolic changes of species. Marine species are surrounded by warmer and warmer ocean water, and organisms are pushed to their biological thermal limits, which may occur reduction of biodiversity, also something that's caused by ocean warming. And then reproductive changes. Organisms are weakened by the thermal stress and do not like.
They don't reproduce well
Yeah.
because of like the hotter environments. Oh,
I would like
brother.
to add on. Okay. Also, an effect of global warming on oceanic species is that, like he was saying, like animals not being able to reproduce properly. A lot of animals are still able to reproduce, but their population sizes are being affected. Like in species like sea turtles, whose genders are affected by the temperature in which they were born with, since their temperatures are rising. Because most female sea turtles are born in warmer temperatures, and males are born in colder temperatures. And with no cold temperatures being around where they usually reside in, majority of the turtle population are females now, which is causing their populations to decline.
Okay. And um I don't know why. And because many marine species rely on ocean-specific temperatures as a sign of reproduction, mating times, egg hatching times, and larval development, the disruption of temperature leads to reproductive harm.
Um, then there's ocean.
Speaking about the ocean, we also have what's known as ocean acidification. Can you tell me what that is, Jaden?
So ocean acidification is the decrease of pH in ocean water. And since the Industrial Revolution, ocean pH has like fallen by 0.1. It was 8.2, and now it is currently 8.
Can I talk about that real quick?
No.
Anyways, um, this might seem like a small change in the ocean's pH, but when you think about it, it's actually a 30% like decrease to
Yeah.
because it's like a 30% no increase in acidity because you know how like when like Miss Alphonse taught us like if you go by point one it's like 100 or like no wait if you go like from a 7 to 8 pH it's 100.
10.
Yeah, that's basically what that means.
So yeah.
Yeah.
So ocean acidification is caused primarily due to greenhouse gases, specifically carbon dioxide. And this process happens when CO2 is absorbed by seawater, and a series of chemical reactions occur, which increase hydrogen ions.
Can I talk about this real quick?
No.
Because
CO2.
because I don't think Jaden's really gonna get it. So the process happens when carbon dioxide plus water form H2CO3, which is also known as carbonic acid. And when this carbonic acid disassociates, like when it starts breaking down, it forms free hydrogen ions H plus, and it also makes HCO3 negative, which is a bicarbonate ion. And hydrogen ions lead to the lowering of water pH. Now, Jaden, can you tell me what like ocean acidification, like what does it do to the organisms? What are the effects?
Okay, so the shells of many ocean creatures are made up of calcium, right? Calcium carbonate, which is
CaCO3.
CaCO3,
Mm-hmm.
right? And they use calcium ions and carbonate ions, right?
Mm-hmm.
So the increased concentrations of hydrogen ions bond greater with carbonate ions and calcium ions, which marine organisms cannot extract from once that process occurs, making it harder for these organisms to build shells. Right? Hydrogen ions also can break existing carbonate bonds, weakening already formed shells and skeletons.
Mm-hmm.
So this also not only affects the organisms, it also affects coral. But wait, that's the organism, right?
Yeah, it's a plant. Yeah.
And coral needs carbonate to form their skeleton, which is harder because,
As we
as stated
stated.
above, coral reefs are particularly vulnerable to climate change and ocean acidification. And like we said earlier, the coral bleaching.
Okay. Um,
Next thing we will learn about is invasive species.
we have talked about invasive species in like the past units, but it is an important topic in this unit as well. So, Jaden, can you tell us again what is invasive species? Like, what is it defined as?
So an invasive species is an alien species whose introduction does or is likely to cause economic or environmental harm or harm to human health.
So, can I give it? Can I give an example?
Actually, I have an example myself.
Oh, okay. Can you
So
tell us?
characters like remember in Unit 3 how we learned about K and R selected species.
Mm-hmm.
Usually, invasive species tend to be R selected since they're able to reproduce really.
In generalist, yeah.
So let's give an example. If an elephant were to come to America, they would not become invasive because what the hell? How are they gonna reproduce so quickly? They
Yeah.
produce one baby like every what 9 months, every 10 months or something.
That's a human.
So
Yeah.
yeah, but then R selected they reproduce at a rapid rate. So like let's say every day,
Mm-hmm.
right? They produce like
Who gonna match my
thousands
freak?
of babies. Like roaches. Like when you see one roach, there's most likely like multiple.
Yeah.
So yeah, so that's how R selected are more likely to become invasive.
So
The zebra musk that
yeah.
we spoke about.
So the characteristics of invasive species is that they have a varied diet. They produce multiple offspring, as Jaden said before. They have short gestation periods. They have little parental care. They reach their sexual maturity faster, and these invasive species tend to have a competitive advantage over endemic, also known as native species, because of lack of the checks and balances of the ecosystem. So I actually want to give an example of an invasive species.
So you know how well we talked about how we just came from America.
Um, but I want to talk about different type of invasive species. So mosquitoes. Mosquitoes. So you know how mosquitoes carry various diseases. Can you share us your own personal story of what can, like the diseases that mosquitoes have in Africa?
So one disease that I'm very aware of that mosquitoes do share, actually two, would be malaria and cholera, which I know a lot of close relatives have gotten from mosquito bites, and it gets like really bad.
We know.
What does that have to do with invasive species? Mosquitoes are invasive species.
Yeah, I'm giving an example of the diseases mosquitoes carry, like how they harm humans. Yeah.
How these invasive species are spread is through the transport of lumber and firewood, the transport of ships and of boat of the transport of ships and boats, the fur of animals and clothing of humans, and wind and water. And the way we can control invasive species, like coming into environments that are not theirs, we can clean boats and vessels to prevent aquatic invasive species, preventing the release of exotic pets, like in aquariums. Like whenever they release an animal into an environment that's not theirs, that usually happens. And cleaning clothes. And we can also add the introduction of a competitor species to this invasive species. We can introduce like the native like the ooh, we can introduce the um
The apex predators of the invasive species.
yes, we can introduce the predator species to the invasive species. Um, we can also introduce species specific. We can also introduce species specific pathogens to these invasives, which basically kills them, but like it won't kill any other species since they're so specific. And we can also use controlled burns for invasive plants. So, talking about species, in what are endangered species?
So an endangered species is a species with a very low population size,
Mhm.
like a very
Like almost
drastic,
close to
yeah, close to zero.
like.
If like let's say, like I said earlier, elephants, like how they reproduce slowly.
Mhm.
If there's like 14 of them,
Do you know what
still
are
be
endangered species?
elephants.
Pandas.
Okay, that's
Yeah.
yeah, but no, the panda that's their own fault. They're dumb. They want to eat bamboo when they're not supposed to. Get up, you lazy. They have to eat so much bamboo because that's not even enough freaking calories for
I'm
them.
pretty sure the bamboos are going like miles of them.
Probably.
Freaking, go eat a freaking bear, like not bear. Go eat like some type of meat or something. Like anyway,
Really?
as habitats are lost and altered due to climate change, many species are threatened by extinction. Some factors may make a species more susceptible to extinction, like being extensively hunted, having a limited diet, like
Pandas.
being outcompeted by this species, and having a specific habitat requirement. So let's go more back into hunting. Hunting is the extensive, like, hunting. The extensive hunting of a species can lead to the loss of a species. And
Mhm.
then poaching, which is similar to hunting, is the illegal hunting or killing of or capturing of animals for sale or profits. For example, like the African rhino. Um, they were hunted to near. I think they did they go extinct or they're endangered
No, they're
currently.
endangered.
So
Yeah.
currently they're endangered because they're hunted for their horns, which people like most people use them for different medicines. Then we have animals may be hunted for food or body parts
Like the tusk of elephants. Yeah.
for medicinal uses like medical research and
Piano keys.
sports.
Which is basic. Yeah.
Then there's also limited diet and habitat, like we
Oh
spoke
yeah, they are
about
used for that.
pandas. These specialists are like at greater risk of extinction.
Mm-hmm.
Specific
No,
habitat
you're not a niche
requirements,
specialist.
limited diets, low reproductive and high gestation periods, and few offspring.
Like
Also
case selected
contribute
species,
to like them becoming endangered.
like we were talking about before.
And
Yeah.
then competition, like we said, spoke
Like we
about in
talked about in
Unit
Unit
1.
One.
Although species tend to reduce competition, ecosystems where trophic relations are disrupted, invasive species competition is increased and scarcity of resources.
And basically, this all like these factors can like lead to the extent like the endangerment of the species.
So species that are better able to adapt to changes in the environment will fare better under changing or disrupted conditions. As species with lower genetic diversity will be less able to adapt. Species can also migrate to more favorable conditions, although migration can rise competition.
And raise
Now, that's an example when urbanization is
urbanization.
urbanization
Mm-hmm.
is becoming more prevalent now.
Mm-hmm.
Many of the species that used to live around here
Mm-hmm.
or had to either move or were killed off, right?
Mm-hmm.
But like we were talking about generalist species, right?
Mm-hmm.
Let's say raccoons. they're able to live with us because they eat like the scraps that we have
Mm-hmm.
and stuff, other things like that. Correct. So now let's continue this.
Would you like to share this slide? Well,
So, okay. Speaking of endangered species, selective pressure, an external factor that changes the behavior and fitness of organisms within the environment. Selective pressures will change in a changing environment, so traits that were once considered advantageous may not be considered advantageous now. Example: resource availability, food, water, habitat, mating, abiotic, temperature, humidity, salinity, biotic, pathogens, and disease. Strategies to protect species include legislations, criminalization of poaching and institution fines and incentives, the Lacey Act, the Endangered Species Acts, sites, wildlife refuges, and national parks.
Yeah, I don't know sites. Now, can you tell us what sites is?
um, FICE is actually forgot what it stands for, but it's basically I literally forgot what it stands for.
That's not it.
It's not, but it's like basically it's just telling people like to control the amount of hunting that they do. Is it not? The next topic we're going to talk about is human impacts on biodiversity. Now, there's a certain what's it called acronym that we use to describe. Yes, tell us, Jaden.
These are the main factors leading to decrease of biodiversity, and I will tell you what each letter means. So
Mm-hmm.
H stands for habitat destruction.
Mm-hmm.
I is invasive species. P is population growth. The other P is population pollution. C is climate change, and O is over exploitation.
Yeah.
Habitat fragmentation occurs when large habitats are broken up into smaller, isolated areas.
Mm-hmm. So how does like what like how
What
does
causes it?
yeah what causes?
So construction of roads and pipelines,
Mm-hmm.
clearing of lands for agriculture or development, logging, and something to also note is not all species are equally affected by the adverse effects of habitat fragmentation. Some species may benefit from fragmentation, especially those that thrive in edge habitats, and specialist species who have specific habitat targets are adversely affected by habitat fragmentation. Edge habitat is the
Defined as
between the two.
he knows one. So basically, what we need to know is that climate change plays a large role in habitat loss, and because as average global temperatures rise, habitats may be lost due to coastal indentation from melting land ice and permafrost, rising sea levels due to thermal expansion, changes in precipitation patterns due to changing atmospheric and oceanic circulation patterns. And because of this, climate change has been more intense in the northern latitudes as warming trends continue. These areas will be more at risk for habitat loss and biodiversity. We also have domestication. Domestication also leads to loss of biodiversity because artificial selection, which is when like they pick out the most valuable traits in a
And
in like a
then
plant
the
species.
final lesson we will learn in this unit is human impact on biodiversity, which is common.
Well, this is how. Well, it's the same topic, but it's like how do we mitigate biodiversity loss?
So these are ways we could mitigate habitat loss from biodiversity. Creation of protected areas like wildlife refuges and national parks. We could create habitat corridors to reduce negative effects of habitat fragmentation. Habitat corridors are like a natural or wildlife strip that connects two core habitats. An example, built, a bridge built above
That way,
the highway. Right? We could restore lost habitat, and then we could also have stable use.
like we talked about in Unit 5.
So now, what? Tell us what you think the most difficult part of this lesson was.
I believe the most difficult part of this lesson.
What?
What do you believe the most difficult part of this year was?
I believe the most difficult part of this unit would probably be um the greenhouse gases because memorizing a lot of the chemical bonds and the greenhouse gases was very difficult. I could never remember all of them during the AP science exam.
Yes.
We agree.
I agree with you.
Okay, so what do you guys think the hardest part of this lesson was?
The hardest.
The
Okay,
hardest
we
part.
just discussed that. I'm bad.
Easiest part. That's a great question. I wasn't expecting that question.
Well, I believe the easiest part was the habitat fragmentation part. So it's pretty simple to understand.
I think the I think the easiest part was the ocean ozone.
The ozone depletion.
Yeah, the ozone depletion. That was the easiest part.
Yeah.
But I actually knew like the effects and like the consequences of ozone.
Yeah, you were yapping, Mr. Yapper.
I think that's it, right?
This is so sad. I know, we're done. Like this is the last time you guys are gonna see us.
Well,
This is very sad. You're not. They're never gonna see us again.
So I guess it's goodbye. I'm Jaden Luciano.
I'm Wealth Clinton with Mike Clagbore.
And I'm Anthony Giovanni Santos Mendez.
And this has been the 80s.
Bye.
Bye.